Okay, so in this video, what we're going to do is we're going to consider the other areas relating to, think of that box that I had with correct decisions and errors of hypothesis testing, right? Type 1 and type 2 errors, and we had 2 correct decisions. We're going to map out all of those areas. We started in the last video by mapping out 2 of the areas, that is alpha and 1 minus alpha. And so now I've done the same thing. So the red distribution here represents if we sample from, it's sampling distribution. If the null hypothesis is indeed correct, they come from the same population, and you're going to have that. And that's why you have a mean with a little sub-zero, which means the that represents the null hypothesis, right? So that's what it would look like. And we have our 95% confidence intervals right out here. And you can get this image from the overheads. That's where I am in the overheads here, but I'm actually going to bring up this so I can draw on it. So we have our 95% confidence intervals, right? And if our test statistic falls over this line to the right of it, right? That's a terrible arrow, but you get the idea. We're going to reject the null hypothesis, right? Because that's unlikely to be due to sampling variation. Or if it falls out here, same outcome, reject the null hypothesis. And what we're saying in reality when we're doing that is that it must belong to some other population. Our groups are so different that they must belong to different populations. So they belong to this other population, really, that's overlapped here in blue, or they belong to this population overlapping here in blue as well. And so that means that just like before, the area that's out here, this small area out here, this is the sample means that belong to the null, in reality belong to the null hypothesis, but because it falls to the right of our rejection line, we're falsely claiming that there's a difference here, right? And so this is represented by alpha, right? Type 1 error, and it's really alpha divided by 2 because you have the same area over here, right? And anything that falls in between these 2 lines and belongs to the red distribution, that's going to be 1 minus alpha, right? So that's what we did last time. But now we have our overlapping distributions. Remember I said that beta and alpha were related, but they belong to different distributions? Well, here's the scenario. So let's suppose, for example, for a moment that the test statistic is out here, right? So it's out here, test statistic is here, and it does belong to a different population, right? And so what we're talking about is we're talking about this entire area that falls to the right of the line, right, and belongs to this blue distribution, right? So it's this area that I'm scribbling in right here. Well, this would be a correct decision, right? You've rejected the null hypothesis when you should. So hopefully as you're following along here, you recognize that this is 1 minus beta. That's the area that's there. And in reality, it's the same area out here, 1 minus beta, okay? But for convenience sake, I'll just draw only on one side. Now, there's another area, right, which is right here. Maybe I should use a different brush or something. We'll try to use a different. I'll use the paint can here. And this area right here, it's sort of right. In this area down here, maybe I can pencil it out. So in this, try again. This area down here, right, all in this area, this would be the beta area. This is the area that represents a type 2 error. That is, it belongs to this blue distribution. So we should reject the null, but we don't. We accept it instead, right? And so they're overlapping distributions, but they're separate distributions. And the 2 errors are related to one another because if you increase alpha, what you're going to do, if you increase alpha, this area is going to get bigger. So that means the line is going to move to the left here, right? So you're going to increase alpha, and yes, your probability of a type 1 error is going to get bigger. But as you notice, your beta region is going to get smaller, right? So as alpha increases, your beta region, by default, is going to decrease. It's an inverse relationship. But they're not mathematically related. In fact, what you could do, we set alpha, right? We determine that. But we can mathematically calculate what's the probability of beta given our particular data set. And more importantly, we calculate statistical power, 1 minus beta, and we want this number to be as big or as large as possible. In fact, anything greater than like 0.8 or so is sufficiently powered, right? That means that we would only have a 20% chance of a type 2 error, okay? So that's how they work graphically. In the next video, we're going to talk about ways to increase this error area, this power area, and how we can do that, because in fact that's the correct decision we want to make. We're doing our studies to find a difference, and we want to maximize the probability of finding those differences when they truly exist.